Alright guys, welcome to this page of notes. Let's go ahead and get a little bit more practice with graphing a relation or a function. We'll check and see which one we've got, and then figuring out is it representative of a function by checking using the vertical line test. So figuring out is it one-to-one onto both or neither. Let's go ahead and jump right into this. I have given you an equation, so we know it's going to be continuous, right? Anytime you get an equation, you're going to connect all the dots, all your plotted points with a line. The only time you wouldn't is if it was just a set of ordered pairs, then it would be discrete. But this is an equation, so we will connect all of our points with a line. And the way you're going to do this is by setting up a table, just like we did previously. I'm going to set up x, y. Again, I'm going to pick points that are easy to do math with. 2s, 1s, and 0s are super easy, so we'll go -2 to +2. -2, -1, 0, 1, and 2. I'm not picking those points because there's anything special about them. I'm just picking them because they're easy, and I like to work smarter, not harder. So here we go. I plug a -2 into the equation that I was given, right? -2 goes in for x, and I have to square it. So -2 squared would be 4. 4 plus 1 should be 5. So my y value is 5. I plug in a -1. -1 squared is 1, and 1 plus 1 should be 2. So I have a 2. I plug in a 0. Well, 0 squared is 0, and 0 plus 1 is just a 1. Now I'm going to plug in a 1. Well, 1 squared again is 1, and 1 plus 1 is 2. So I wind up with a repeat value. That's okay, but that shows up twice. I have 2 twice in my range. I plug in a 2. 2 squared is 4, and 4 plus 1 is 5. It looks like I get another repeat value. 5 shows up twice in the range. But let's go ahead and plot my points, see what this looks like. I'll plot my points in red. That's how we'll graph this guy. So we're going to start with -2, 5. -2, 1, 2, 3, 4, 5. There's my first point. -1, 2. Then I'm going to have 0, 1. I'm going to have 1, 2. And I'm going to have 2, 5. 2 and 5. Right? So remember, it's always x, then y. Horizontal axis is the x. Vertical axis is the y. Let's connect those dots with a line. Let's make it continuous. So here we go. It looks like it probably does something like that and something like that on this side. All right, now the first thing I ask you for is figure out the domain and the range values. Well, let's go ahead and do that. So the easiest way to do this is going to be for domain. It looks like what's going to happen here is because it is squared. Anytime I plug in a negative number for x, you square a negative number, it will always be positive. So it doesn't matter what negative number I plug in. This function will never, ever be negative. Ever. It's never going to be negative. But that doesn't apply to my domain because I am choosing negative values for x. And the x values are my domain. Are there any values for x that you can think of that you wouldn't be allowed to plug into the domain? Well, the answer is no. You can pick any value of x that you want to. Pick your favorite number, plug it into the function, and it will work. What that means is that the domain is going to be all real numbers. You can go to -infinity, you can go to +infinity. Every single real number will work. So my domain will be all real numbers. Remember, the domain is just simply all values of x that are allowed to be plugged into the function. And there aren't any that I can't plug in, so all of them are allowed. All real numbers is my domain. But let's come back to that idea of what I just said a second ago. If I do plug in negative values, I'm still going to get out a positive range value. Think about it. Plug in any negative value you want. When you square it, it's going to be positive and then I'm adding a number. It's always going to be positive. This y column will always be positive. It will never be negative. What that means is that my range is restricted. This is the smallest value for y. My function's never going to drop below that. So what about all these values down here? Well, they're not part of your range. Positive 1 is your smallest value. So your range is going to be all values of y that are greater than or equal to my smallest value, which is 1, right there. That is my smallest value. In fact, let me go ahead and circle it for you right there. That is the smallest. You're never going to get a y value smaller than positive 1. Pick a few values and give it a shot. I guarantee you it's never going to be smaller than 1. So what that means is that every single y value will always be greater than that, so I need all y's greater than or equal to positive 1. That's going to be your range, all right? You're never going to get anybody down here, all right? So there's my domain, there's my range. Now I ask you to figure out, is it 1 to 1? Well, that's easy to do. The vertical line test. Go ahead and start drawing vertical lines on here, and what you're looking for is, do your vertical lines ever touch the graph more than once? Well, let me draw a couple just to show you. I'll draw a vertical line here. I'll draw a vertical line here. I'll draw a vertical line here, and I'll draw a vertical line maybe right here. All right, there's a bunch of vertical lines. This one comes down, it touches the graph right there, but that's the only place it touches it, so that one's okay. This vertical line comes down, it touches the graph right there, but that's the only place it touches it, so we're okay. This vertical line comes down, touches right there, but that's it, that's the only spot. This vertical line comes down, touches right there, but again, that's the only spot. So it looks like every vertical line only touches the graph in one spot. That is our definition for the vertical line test. And so yes, we passed the vertical line test. This is 1 to 1. And yes, we have a function. So the things I'm going to be looking for you to do. First, is it discrete? Is it continuous? If it's a set of ordered pairs, it's discrete. If it's an equation, it's continuous. Give me the domain and range once you've graphed it. The domain is going to be all possible, all allowable values of x. Most of the time, it's going to be all real numbers. Most of the time. And then the range, you're looking for all possible or all allowable values of y. Well, just look at your graph. What values of y are not part of your graph? What values of y are? Write your range, and then use the vertical line test to figure out if it's 1 to 1 onto both or neither, and if it is a function or not. Of course, if it passes the vertical line test, if it is 1 to 1, then yes, it will be a function. Let me slide that up just to make sure that you guys can see it. It is a function. That takes care of the problem on this page of the notes. Head on over to the next page of the notes, and I'll meet you there.